I'm going to go ahead and start recording and share my screen.
Yeah, I just needed to try to get an understanding of how to even start on the Lab 32 for the functions 2 part.
All right, now, well, let's see if I still got it open or closed it. Yeah, okay.
Yeah, that one.
All right. Marissa and I were talking about it a little bit before. If you read down, it tells you what functions you need to create. So the way I would do that or look at it is I would come down and I'd say, okay, I'd on paper make a list of the functions that I need. So the first, create a function that receives the values and returns the total resistance. Okay, so I need a function, and these are not necessarily in the correct order. Actually, okay, so create a function that will receive the values, 2 resistors, return the total. Okay, so I would write down I need a function for total resistance. And it shows you the calculation. Create a function that will receive the values of 2 resistors and return the total parallel resistance. Create a function. So I would go down through it and make a list of those functions. Let me say, come over here. And so the way I would probably approach it is come in and say, okay, we need a function. And these won't necessarily be the way you'll name them. So I'd just go through and I would make myself a note on what it needs. Okay, create a function to ask the user for the resistance. And then create a function to print the 2. Okay. So I would write down, either on paper, I'm typing it in, what functions I need. Then I would go up, and even if this wasn't functions, this is my thought process for how I work on programs. So what do I need on one to ask for resistance? Do I need to pass it anything? No, I don't need to pass it. I need to return a resistance. And then there's no calculations here, but I'll say ask user. So I get myself an idea of what I need. Up at the total series, I would say, okay, I'm going to pass it 2 values. I'm going to return a value. And then I'm going to calculate. And in my notes here, I may or may not put the calculation, but I will here. Say maybe R series is equal to R1 plus R2 if those are the resistors there. Do the same thing for the parallel. And then here in the print function, I would pass it R series and R parallel. So, and then print both. So I would start by using notes to figure out what I want to do. And then now that I've not got those, or I've got the functions that I need, let me clear this one off. I would use those notes. Todd's decided to join us.
Better late than never.
Huh?
Better late than never.
That's okay. Small group today. And so I've created my list of the functions I need. Again, they don't have to be in any particular order. So here's where I would actually figure what I'm going to name them. And so maybe the one that asks for the resistance, maybe I would call it get resistor. Now, we said we weren't going to pass it anything, didn't we? So just the parentheses here with nothing else. Okay. What's going on? There we go. Maybe. I'm getting that pausing issue that I sometimes get with the recording. There we go. So in it, then I'd have my comments as to what I'm doing. And then I would have my code. And I'm not going to finish it, obviously, because that would finish it for everybody. And then the return value. So whatever there. And then I would do that for each of them. Now, let's go ahead. One of them that I've got to pass it something. I've got to pass it the 2 resistor values for the series. So here it's slow again. There it goes. Maybe. I forgot to reboot the system. I usually try before class to reboot everything, and that anything in memory that might be going too, but it hangs up here because of there. So maybe I end up calling it calc series, but in it I'm going to have to pass it things. So say maybe I'll pass it R1 and R2 because I've got to calculate the total of 2 resistors. Then I would do my calculations, and in it I would return, let's say we end up calling it say total. Although I've got the curlies because total's not there. And you do that for each of the functions. Now up in main to call it, I've got to get 2 resistor values. So I would say maybe R1 is equal to get resistor. R2 equals get resistor. Because each time it's going to return a value of whatever we've gotten. And then what do we call the series one? Calc series. Then we say total series is equal to calc series, and I'm passing it R1 comma R2. And you'd continue that way. So I got there's a really good start for that one. And again, the way I do it, I don't ever start coding right away. I either on paper or in this case in Notepad++, I make myself notes, and the more detailed the program is, the more detail that is, so that hopefully I don't forget anything. And then you just continue that way. Okay. So that's the way it just in general I approach programming, and especially with functions is, you know, I go in this case, read the lab, or I would read my design document. If I was designing a program from scratch just based on parameters, I would probably be creating the design document as I go. I'm giving you sort of a design document here. And so that would be a start. Okay, that help, Caleb?
Starting to help.
Okay.
Mr. Perry?
Yeah.
Could you clear my Dropbox for lab 31?
You should be able to resubmit. Is it?
When I click on it, it only shows what I last submitted.
Okay, I know what you're doing wrong, and let's see. If I can find a Dropbox real quick, I'm going to unshare my screen a second, and I'll show you.
Okay.
I
got it.
Okay.
Yeah.
Yeah. You were clicking on where it showed the submission
yeah.
and not the ad. Yeah. You're not the first one that's done that this semester.
Okay, I got it.
Okay.
Thank you.
Okay, no problem. All right. Okay. Other questions about functions while we're on it?
Hey, Mr. Perry.
Yeah.
And you may have already answered this. I need to go back and watch the other videos you've uploaded to YouTube. I watched all the ones for that you've put on the class folder.
Yeah.
Lab 31, it says to use 2 functions.
Mm-hmm.
And like I said, you may have already covered it. If I need to go back and watch something, let me know. I think I'm only using 1 function. I'm getting the right output, but I don't know if I'm doing the right thing.
Right. You can certainly do it with no functions. I mean, this is not one that's hard to do, but I wanted you to do 2 functions just to do 2 functions. So in it, let me scroll down here and get me some blank. In it, you're going to iterate through the list. So you would start where you had your list, say list 1 equal the list here, and to iterate through the, any of the ways we've done it, for loop's probably easiest. So a for loop, but the functions, you would have a function. I probably should do this in actually in PyCharm, but you need a function for odd.
Okay.
And then another function for even.
Okay. I done 1 function that did even and odd, so I need to separate them.
Yeah. You want it, and it really, you look at it, you go, doing functions in this one actually more complicated, and that's true. But the idea is this was your first creating a function, so make something that's kind of easy. So in the for loop, each time you go through the for loop, it's going to be another value, and then you're going to check and see if it's odd or even, and then call the odd or even function that prints. Again, it's kind of, I want to say trivial, because for me it is, but for doing your first function program, it's not.
Gotcha. Okay.
All right.
And I'm going to go ahead and, I'm going to work on that. I just, in my for loop, I would just have both functions in my for loop.
Yeah. What in the for loop, you would have an if statement.
Okay.
that
I'm right there with you.
if whatever your parameters are, you would call odd if the function you called odd, and then an else statement. And of course, this is not correct syntax, folks.
Right.
Or the opposite way around, whichever way you end up doing it, odd and even.
Perfect. Thank you.
Okay. All right, others. Okay, close these out. I have posted 4 more labs. These are bonus labs. Don't got to do them, but they are bonus labs. They deal with reading and writing files. The way, and I know I sent it out in an email, but I'll say it again. The way I do it, you've got 33 labs, and so that's 3,300 possible points there. This extra 4 labs or another 400, I will add up all of your lab grades, including those, and divide it by the 3,300 to get your lab grade. So it is possible that someone could end up with a lab grade over 100. I'm not sure there's more than maybe 1 or 2 people that have everything 100 for every lab, but it's possible. So those are out there now. All right. What I was going to do today is look at a little error handling. And I've always torn as to when to introduce this, but most books I've read do error handling fairly late in the game. I've thought about trying to do it early on, right after, especially just adding some error handling after we do inputs. But I'll be honest with you folks, there are a couple of folks, none of you guys, but there are a couple of people that are still struggling with input and print. So because of that, throwing in error handling early on probably would not be a good plan. In its simplest form, I'm going to copy some code because it's easy to mistype this one. I've set up a while loop here and said while true. Well, a while true loop, you think, oh, that's an infinite loop. You're never going to get out of it. And if it weren't for somewhere in there being a break, you're right, you wouldn't. Now, this is not necessarily the only way to do this, but let's say we need to input a number. How many times when you've tested your programs, you entered something other than a number when it tried to convert it to an integer or to a float, you got an error. We've all done that. I've done that typing the examples because I've not paid attention to what I was entering. So you've got what's called try and except blocks. The try says, try this command or commands. It could be a series of commands. If it generates an error, instead of showing that error, let's go and let's give you an error message and let you know what's going on, rather than those traceback errors. If I pull out my try and accept and try and run this, it asks for a number. If I put in something that's not a number, I get this traceback error. You don't want that when the user is running the program. You don't want them to get an error and the program basically crash. So by using the try except block, and in this case putting in a loop, so it's going to keep asking them for a number because of the while loop until they type a number in. So it says enter a number. I type a number in and okay, it exits out of here because it was able, there was no error generated, so it broke out of the while loop and whatever was next, which was the print X. But if I run it and I put in anything that's not a valid number, oops, that's not a valid number. It goes down to the except, and the exception we're looking for is an error in the value. So it does that, and we said, okay, oops. And because we're in this while loop, it goes back up and asks for the number again. If I type in 3 space F, that's not valid. Same thing happens. If I do 4.4, well, that's a number. Well, I've said convert it to an integer. That is not a valid integer. So I probably actually, my message should say integer, but as soon as I put in a valid integer, it exits that. So if we wanted to make sure that values that we wanted were legitimate, we can use this try and except type block. Another way of working with it, maybe it has to be in a certain value range. So if I said enter a number between, or let me just say less than 10, and it could be a negative number. And if, and I could, well, my try actually should, I should actually have another try block here. So I can nest these. So if I get something that's not a valid number, it's going to give me the exception. So I try this one and say if X less than 10, well, that would be valid, break. And then my except and whatever my value error is here, except, let's say print invalid number. So here I've actually nested it. Let's see if I've got any typos. So enter a number less than 10, enter a 4, and okay, it did this try, that was true, and it did the break. Let's try it again. And let me put in 33. Okay, it did not. Okay, try.
You need value error beside you accept there in your.
Oh, yeah. Well, the value error is, I bet, yeah. Yeah, I bet. Let's see, try. That's true. Okay, what's my, so it's going to try that. If X is less than 10, that's valid.
I think your second break needs to move over one.
Yeah.
The second one.
Yeah, I bet that's, so yeah, I bet you're right. And I'm going to put a pass because it has to have a command of some sort.
I think he's talking about line 24.
Line
You got
24.
indented. You got indented too far, don't you?
No, it
No,
should
you
be,
don't.
it should still work inside the try.
Okay.
Pass is actually a command that says just skip that, and it's usually in there for testing. If less than 10, so it's actually doing the try. Let me make sure it's getting in there. I'll put a debug in there. And we'll put 100. Why didn't it debug that? Oh, I had my mark the wrong place. And I just ran it. I'm not sure why they don't have a shortcut for debugging. Okay, so it is at the if. If that's true, it's probably the exception. It's probably not a value error that I need. If that's true, I really can pass. It's probably the error type here. It's not actually a value error. And that's probably what it is because it would come out false. But I'll have to look at the error type. But you can nest them that way, and I may look up the error type in a minute on that. Because if that's false, it should do the exception. Now,
Will that only work if you actually crash the program instead of having a false?
well, that's where I say I think it's not a value error; it's another error type. And I'm drawing a blank. I will show you there are some different error types. There is, for example, a zero division error, which is what I was going to do next. But there are OS errors, errors if you try to open a file. That would be there. So that's probably the problem. Is it's the error type that I'm using wrong, and I'll have to look up that. I'm drawing a blank right now. After a while, I'll go, duh.
Yeah, but there wouldn't be a logical error with that statement, would there? To cause it to crash.
Well, there's an exception that if that statement, if an if statement is false, and that's why I'm thinking that it's the error type. So yeah, there's not a traceback error, but you can trap. You're basically trapping a value. And again, I'm drawing a blank on what the error type is. That's what it should be. Here is a very typical thing you have, and this is, for example, a division or zero division error. So if I were to set, and I'm hard coding it in, but we don't know how they got those values, num1 and num2, 10 and 0. Well, first, if I run it at 10 and 10, X is not defined. That shouldn't be X. That's from before. Num3. It'll print the 1. 10 divided by 10 is 1. But if num2 is 0, if that denominator is 0, okay, it's still getting my, shouldn't get the error. Print num3. Oh, num3 doesn't exist because it failed on the try. There we go. So now it gives me the error, zero division error. Now I'll probably do something else rather than just print that value. But this is a very common one when you're doing math operations that involve division. If you are doing math operations involving division and there's any chance that that denominator could be 0, this zero division error is something you always want that math operation in. In this case, I have printed an error, and I've done it a little different. I said exception is zero division error as ERR. What that does is store the error message in ERR variable, and I can then print it out. So I said error is division by 0. That's the actual error message that was generated. So I can use that by generating a particular error message to print and customize my error message. If I go back here, I have customized my error message, but I don't know what that value error actually was. If I change this to, well, let's see first. This is 94. If I change this to value error as ERR again, and I'll leave that first print as is, just add another print line in here. And so it has added invalid literal for int with base 10. So it's actually, that would be the actual, that's the actual error message that generated. You may not want that. In this case, I probably wouldn't. What I would really want is just, you know, that's not a valid number, try again, but you can do that. So here, the zero division error is what we used. There are a number of different error messages, and we could spend all day just looking at all the different ones. But yeah, here's one. Is this the end of it? Yeah. Okay. And I need to get my indents right on this now. This one, I'm going to try to read a file, and notice there are several exceptions here. And I don't need this raised. That's not supposed to be there, I don't think. There are several exceptions here, depending on the kind of error. If I try to open, and I need to open it for, say, for reading. If I try to open this file, it doesn't exist. And my indents, oh. I wiped out my defined main. Okay, the file doesn't exist, so it looks at the errors, and the error that it generated was this OS error, which is that the file does not exist. No such file or directory. No such file or directory. Now, if I had a file that was my file.txt, because in the try, I'm doing 3 different things. I'm trying to see if the file exists. I'm reading the file. I'm going to strip all the white space out and try and convert it to an integer. So I'm trying to do, in the try, I'm doing multiple things, so there could be multiple error types. Let me now create the new file, and my file .txt, and I'm going to just put a number in there the first time, and so it should not generate that error message. And it didn't, and I'm not printing anything after, but it was able to run this one. Actually, let me come here and print S. So it's printing that 3. If I change that to George, now I get the error, could not convert data to an integer. It is printing George down here. So I did get an error. In this case, I would probably might want to put it in a loop or exit the program. What I actually really want to do other than print the error message doesn't matter. So I've got one try block with multiple commands, and I've got different exceptions. And this last except is, well, if there's any error other than those 2, if you have an except with nothing else, it's just if it generates any kind of error. But it's better to categorize the errors on it. So here we see that we can generate, or we can use our error handling, in this case, to make sure that file exists. If we open it and it didn't exist, then I got the OS error that the file didn't exist. Otherwise, couldn't convert. So again, different error messages depending on what I want to do. And let's see, scratch 6. Here's another example of trying to open a file where we've added an else to the try. So try this. If there's an OS error in this case, it can't open the file doesn't exist, do this exception. Any other cases, it's going to do this. So you can actually even have an else in part of your try block. So it said, okay, I was able to open this file up, and it was there, and so, okay, print this information if any other errors are generated. So the try except blocks are a very powerful, very good error handling method that we can use. Where probably the 2 places I use them the most is when I'm trying to open and close files to make sure the file exists. And if we go back, with input, and of course the 0 division, I guess, goes without saying, but where I am inputting data and I'm trying to validate the data is correct. So try that it's there. Then you could have another try block to make sure it's valid, and as long as it's not, or it's valid. You could also put that, making sure it's valid, if in the case of the input, if they enter a number but it's not in the right range, you could have a loop here to re-ask as well. But that's an introduction to error handling. And if you're doing a lot of programming, especially programs that other people are going to use, handle errors or do whatever error handling you can using these try blocks. All right, any questions there? This will not be on the final, other than in the programming parts. I may say, if there's some cases, I may tell you bonus points for using a try except to catch errors. But there won't be anything on the final that will require you to do it. Okay. Any questions? As the world is quiet.
If you're done with lecture, I've got a question on lab 33.
33. Okay, let me bring up 33. Okay.
Ready.
I've got it all down except for the second function to find the next number from the previous two numbers.
Okay.
I'm trying to figure out how I would
Pass it the right
grab
values.
the last two. Yeah.
Okay. If you have a list, where's my notepad? I've got a list, L equals what's the E, and I can't count because this list size changes. How would I get the last two values of the list?
You do an index and or end. Something
Well,
like that.
there's an easier way, or well, the easy way. The last would be what?
-1.
-1.
Okay.
And the next to the last would be
-2.
-2. So if you pass the values that are stored in those two to your function, you'll get the next two. You'll be able to calculate the next value.
Okay, so I would just pass my list into my function, right?
Actually, I think you just pass the two values from the list. Let me see. Write a function, how many numbers? Write a function that will find the next number by passing. You're only going to pass it the two values. So if your function was called nextNum, for example, you would pass it L of -1, comma, L of -2 would be what you would pass it. And that would pass the last two numbers. And then you would end up returning whatever the next number is in N. And in the function, you would calculate the next number by adding those two values.
Okay.
Okay?
Yeah, sounds good.
And Fibonacci sequences are a very common mathematical problem.
So would I print my next numbers in main, or would I print in my next function?
You want to, when you return, let's see. When you return that value, you want to add it to the list, okay? So you've created the list before, you create the list before you, a blank list. Remember, you create a blank list by saying
Open
like
bracket.
L equals there. So you'd create your blank list, and you could actually go ahead, okay, it actually says starts with, so you instead of creating the blank list, you're going to create a list that starts at 0, 1. So the list would start there. And then you ask how many numbers in it. And then each time it returns this value, you append it to the list until the length, and so you're going to have a loop, probably a while loop, until the length of the list is whatever you said. So if you said include 100 numbers, you would go through the loop until the length of the list was 100.
Okay, so when you want us to print the next number, it's not just the next number, but the whole list in
Right.
the added number?
Right.
Okay.
After you get it, once you have got all the numbers in the list, just print the list.
Okay.
You don't have to worry about printing the numbers on the next line. Printing the list in list form like this is fine.
Okay.
Okay. Other questions? We lost somebody.
Chris.
No. Okay. Other questions, folks? These are good ones. All right. Well, if there are no other questions, we'll go ahead and stop here. Tomorrow, I'm going to introduce you to classes. We definitely will not cover classes on the exam. So anything we cover as far as new material here on out, which are going to basically be introduction to classes, will not be tested. It's stuff that I always get at the end. I never test on because we don't have time to get into it much. But classes in object-oriented programming are a way of grouping things together, tasks and all together. And so we're going to just hit on that tomorrow and probably Monday. Next Tuesday and Wednesday sessions are probably just going to be question and answer sessions for you guys to bring in any questions and things. Okay. All right. And so if nothing else, we'll see you guys next time.
Have a good one, Mr. Perry.
All right.
Thank you.
Thank you.